Hi everybody. We have today just the arithmetic combinations of functions, and we get sum, difference, product, and quotient. And when we have an f of x and g of x, and f plus g of x is simply, when we want to simplify it, f of x plus g of x. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x, and f over g of x is f of x over g of x. That's all you have to do, and that's all we're going to do to simplify these. So I've got three examples here. I'm using f of x being x squared and g of x being 1 minus x. F plus g of x, I have to find that first. So that's f of x plus g of x, and f of x is equal to x squared, and g of x is equal to 1 minus x. So we're going to have f plus g, hopefully you're making that out, of x equaling x squared plus 1 minus x. And if I make it look a little more acceptable, I'd write x squared minus x plus 1. And then it says find f plus g of 2. Well, f plus g of 2, we'll take what f plus g of x is and put a 2 in place of the x. So I got 2 squared minus 2 plus 1. That's 4 minus 2 is 2. 2 plus 1 is 3. All right. Next, f minus g of x. We have to take f of x minus g of x, which would be, in this case, x squared, that's f of x, minus g of x, which is 1 minus x, which is x squared minus 1 plus x. So when I write, I did that again. Oh, mercy. Okay. F minus g of x, when I simplify, I'm going to go x squared plus x minus 1. And then f minus g of 3, let's replace all these x's with 3's. 3 squared plus 3 minus 1, that's 9 plus 3 is 12. 12 minus 1 is 11. All right, f times g of x is f of x times g of x, which is x squared times 1 minus x. We're still using those, that's how we're keeping those definitions of f of x and g of x for these first three examples. I'll change it for example 4. And I'm getting, if I distribute, x squared minus x cubed. X squared times 1 minus x squared times x. So f times g of x equals x squared minus x cubed. And then we're asked to find f times g of 3. So we're going to take 3 squared minus 3 cubed. That looks like 9 minus 27, which is negative 18. All right. Last one is the quotient. Okay, we're just going to ask, we're going to find f over g of x, find g over f of x, and then we're going to find the domains, and that's where we need to think a little bit. So f over g of x, that's f of x over g of x, which is the square root of x minus 3 over the square root of 16 minus x squared. All right, that's all there is to it. We're not going to try to rationalize the denominator. We'll just leave it like this. G over f of x, that's a g of x over f of x. And that is equal to the square root of 16 minus x squared over the square root of x minus 3. Okay. Now, for the domain of f over g, notice we have the square root of x minus 3. We have to have x minus 3 greater than or equal to 0, which means x is greater than or equal to 3. Now g of x is, now this is a little bit trickier. So I got 16 minus x squared. That can't equal 0. Okay, I don't know why I just wrote that. But 16 minus x squared has to be greater than, it's got to be greater than 0. It cannot equal 0. You could figure out if 16 minus x squared equals 0, you can take the square root of 0. But we have to avoid 0 in the denominator for f over g. So I want to just show you something here. 16 minus x squared has to be greater than 0. So we kind of did that. Some definitions when we were on the last test. We talked about when is something like f of x greater than or equal to 0. Well, let's just look at when f of x is greater than 0. So I'm going to, or let's just look at when 16 minus x squared. So y equals 16 minus x squared. And now let's look at the graph of that. Okay. And I might go up, just where you can see the top. Not that you need to see it, but let's just go up to 20 there and look at that. And I am pretty certain that you could see negative 4 and 4. So from negative 4 to 4, we are greater than 0. Negative 4 makes it 0, 4 makes it 0. So the solution there is x is less than 4 and greater than negative 4. Okay. Now, we need for x to be greater than or equal to 3 and for x to be less than negative 4 and greater than, less than 4 and greater than negative 4. I want you to just consider that on the number line real quick. So I got negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. All right, so it has to be greater than or equal to 3. So greater than or equal to 3, we would go like this. Has to be greater than negative 4, not equal to, and less than 4. So from here to here. Okay, the only part that satisfies both of those have to be satisfied. So the domain of a is f over g would be from 3 to 4, but not including the 4. 3 is inclusive, 4 is not. All right. Now, on the other hand, when we have the domain of g over f, okay, we can be 0 now. And we've kind of gone through this already. For the numerator, for g, x has to be less than or equal to 4, greater than or equal to negative 4. For the denominator, now the table's kind of turned. We cannot have 0 now. The square root of x minus 3 is down here, so x just has to be greater than 3. All right, and if we think about that, if you look at the number line, I would have an open circle there, and I'd have these both closed. So the domain of G over F, we don't want to include 3. 4 is okay, and that would be the domain there. Okay. You guys have a good evening.